Right, hi students, welcome back. In today's video, we are going to do assignment 5.3, and it's a very interesting assignment because uh, we'll be playing around with the three laws: the product law, quotient law, and the power law, and also some special cases. And in question 3, we'll be seeing how we can actually represent numbers in different forms. All right, so this is really a very interesting assignment. Okay, so don't give up. Right, let's look at question 1. Actually, I started off with doing the most difficult questions, the advanced questions, and then I slowly work up to question 1, which is not the correct order. But of course, for me, it's easy lah. I've already know all these concepts well in my head. Right, so for you as a student, you should start off with question 1, or whichever questions that you have confidence managing. You don't necessarily need to start with question 1 or start with question 15. You start with your favorite questions or your favorite numbers. Okay, right, question 1a. So it's supposed to convert it into logarithmic form, right? So like what I'm going to mention later on, you see, I need to do the reverse. Okay, because I've mentioned this already, because I start from the last questions upwards. All right, which I've mentioned. So I cannot say I mentioned previously. I must say I'm going to mention later on. Okay, that they always start with the base. And in this case here, the base, this guy here is base. 3 is the base. 3 is the base. So log, then the base. Okay, and then 1/9 equals to your power. Okay, so you look at B. So it's very easy. Once you just remember what I've said, start off with the base. Always start off with the base. So 10. So log base 10, then 5 equals n. Okay, so log base 10 is common log, right? So we need to replace it with the symbol lg. So this is one extra step that you need to do. Okay, that's it. Right. Let's look at question 2. We're supposed to convert each of the following into index form. So this is the very basic concepts that you need to learn. All right. Yes, converting from one form to another. All right. It's not difficult. It's really not difficult. Why not difficult? As in, you just need to zoom into the base. All right. The base is very important. The base will provide for you the support. Without the support, you will collapse. So just look at the base here, and that here in 2a, we're dealing with base 5. Okay, so start off with 5, then 5 to the power of 3 will just give you 125. And that's it. All right, and that's it. Okay, let's look at part C. Ln. Ln means log base E. Okay, so very important concept here. It's Ln means log base E. So the base here is E, talking about E. So E to the power of 2 is equals to X. That's it. Okay. Right, let's look at question 3. Question 3 says that without using a calculator, it does not mean that you cannot use a calculator to evaluate, for example, square root 256. You can still go ahead and use a calculator. It just means to say that you have to show the steps properly. All right, and then you're supposed to evaluate means to find the value, evaluate means to basically just find the value lah. Okay, let's look at 3C. So, okay, before we do 3C, let's recap all the rules that we have learned. So we have learned product law. So basically, product law means if you have log base AM plus log base AN, this one can be combined into log base A then MN. And then we learn quotient law. So quotient law is if you have log base AM minus log base AN, this can be combined into log base AM over N. And you also learn your power law, which is if you have log base AM to the power n, basically that's a power there lah, the exponent there, you can just bring down your power. And also some special case such like log base AA is 1, log base A1 is 0. Okay, these are the two special cases also which comes in very useful. handy, comes very handy when you're solving questions involving log. Okay, so let's look at 3C. So 0.125, it's a very it's a decimal number. Okay, decimal number. So sometimes when you look at the number, you can actually express a number as a fraction. You can also express it as a decimal, right? So likewise, what we're going to do here is we're going to express your 0.125 as a fraction, and that will give us 125 over 1000, and if you simplify it further, you'll be 1 over 8. Okay, so 1 over 8, so we have a single log and 1 over 8, so we can actually apply our quotient law. Apply the quotient law here, this one here. So that will give us log base 4 1 minus log base 4 8. Okay, and log base 4 1 is a special case. The special case here, which will give me 0. So 0 minus log base 4 8 will just basically be minus log base 4 8. Okay, and here I think what I'm going to do is there are two ways of doing, from here onwards there are two ways. One way is just to rewrite 8. Write 8 as 4. Okay, so 4 to the power of x equals to 8. So I'm going to solve this. I'm going to find the values of x. So 4 I can write it as to the power of 2, and 8 is to the power of 3. So 2x is equals to 3, x is equals to 3 over 2. So what we are saying is 4 to the power of 3 over 2 is actually equals to 8. And you can actually use a calculator to verify it here. Okay, so one way of doing it is to rewrite it as 4 to the power of 3 over 2. Then you use the power law to bring down your power to get negative 3 over 2 log 4 base 4. And log 4 base 4 is 1, so basically you get negative 3 over 2 times 1. That gives you negative 3 over 2. So this is one way of doing it. A second way is just to change it to base 2. Okay, change it to base 2, then this is how you get it. So log base 2 8 over log base 2 4. So 8 is to the power of 3. And 4 is to the power of 2. So apply your power law, you get negative 3 log base 2 2 over 2 log base 2 2. And log base 2, okay, this 2 can be cancelled off, so definitely, finally you get negative 3 over 2. So this is a second way of doing it. So it actually depends which one. If you can use the first method or the second method, which is the change of base. Alright, so change of base, let's recap. I forgot to recap that. So let's say if you have a log base A, B, if you want to change it to log base C, let's say, right? So we just start off by writing down what the base that you want to change to. So base C, and then the original base A will go to the denominator, and then B will go to the numerator. Okay, let's look at 3D. Okay, I think for 3D, we can just apply the change of base straight away, because you have this base half here, which is quite, should I say irritating? Because we are used to dealing with the integer, base where it's an integer, but now we're dealing with fraction. So let's just change it all to base 2 easier lah. Okay, half and 8 base 2 easier. So we're going to change to base 2. So log base 2 8 over log base 2 half. Okay, so 8 is just 2 to the power of 3. So that will give us 3 log base 2 2, right? And half is 2 to the power of negative 1. Half is 2 to the power of negative 1. Okay, half is 2 to the power of negative 1. So I can bring your negative 1 down. That will give me negative log base 2 2. Okay, so the log 2 base 2 and the log 2 base 2 numerator denominator can just cancel off. So I would have 3 divided by negative 1 give me negative 3. Okay, that's how you do 3D. Alright, let's look at 8a. 8a, what are we supposed to do? We're supposed to express y in terms of x. Oh, okay, that's not too difficult also. Right, so what we need to understand is I'm going to take negative x, add x to both sides, so it will become x on the right hand side. Now to express y in terms of x means I need to get rid of my ln. So ln is just log base e. And the earliest two things that we have learned involving log and index is able to change from log to index form and from index form back to log. Okay, so this is exactly what we're going to do here. Zoom into the base. We always start off with the base. Okay, the base is very important. Without the base, you'll collapse. So the okay, don't get so agitated. So the base is the most important thing. So if you look at it carefully, zoom in, the base is e. So e to the power of x is equals to y plus 1. We need to make y the subject. So y plus 1 is equals to e to the power of x. Subtract 1 on both sides, so y is equals to e to the power of x minus 1. And that's basically how we do 8a. Alright, let's look at 8b. Okay, 8b, right, you can just divide by 2 on both sides to get log y equals to x over 2 minus 2 over 2 gives you 1. Or you can just combine them. Okay, and then LG, it's the symbol for log base 10. Right, so zoom into the base again, which is 10. So 10 to the power of x minus 2 over 2 gives you y. So you're supposed to make y the subject, so write it this way. So the learning point in this question is you need to know that LGY is a symbol for log base 10. And LNY is a symbol for log base E. So these are the two very important concepts here. And of course, then you must know how to convert log into index form. So three very important concepts here that you have to master in order to do question 8. Alright, let's look at question 9. Question 9 is actually a very, very good question because it tests you on the very basic concepts of your understanding of the logarithmic functions. Whether how much you actually understand the logarithmic function. It is not just memorizing the laws of the logarithmic functions. It also need to know the conditions that the conditions that we need to have in order to be able to apply the three laws correctly. So what are the conditions? So if you were to recall early on, we learned that for log base ay to be defined, okay, there are certain conditions, right? First of all, your a cannot be equals to 1, a have to be more than 0, and also y has to be more than 0. Okay, so let's look at 9a. So ln bracket x squared minus 2x is just log base e. Okay, ln is the symbol for natural log, and it's just log base e. So if you were to look at the base e, definitely base e we know is around 3.71 blah blah blah. It's definitely not equals to 1, definitely more than 0. So we don't really have to worry about the base. What we need to be worried is x squared minus 2x must be more than 0. And if you look at x squared minus 2x more than 0, that will remind us of the chapter under solving quadratic inequalities. Okay, and here we need to factorize it. So the common factor is x. And if you were to recall, if you cannot remember, please revisit chapter 1 or 2, solving quadratic inequalities. Okay, first of all, we need to find the x-intercept, which is x equals to 0 or x equals to 2. Then the next thing is to draw your quadratic curve. Basically, the two x-intercept is 0 and 2. It's a U-shaped curve because the coefficients of x squared is 1. Alright, and we are interested in the values that it's above your x-axis. So this part of the curve we are interested in, so the corresponding x value will be anything that's less than 0. And the other part that we're interested in is the other part, the right side. So the corresponding x value will be x more than 2. So basically these are the two inequalities for 9a. So how about 9b? Alright, so 9b is a bit more complicated because you have to worry about the base. We don't know what kind of values x will take, so therefore x cannot be equals to 1. And x minus 3 must be more than 0. So from there, x must be more than 3. Okay, the question asks for the range of values of x. Okay, so therefore, for log base x, x minus 3 to be defined, x basically just need to be more than 3. Okay. Alright, let's look at question 12. But before we do question 12, let's do some recaps of all the 3 laws that we have learned. Let's start off by looking at the product law. So product law means that if you have log base a m plus log base a n, basically that will give us log base a m n. And then if you have a log base a m minus log base a n, that will give us log base a m over n. So this is our quotient law. So if you want to do this chapter well, it's very important that you remember all these laws properly. And then the third one, of course, is your power law. When I said remember them properly, meaning you must know when you can use it and when you can't use it. And when you use it also, how is it to use it correctly. Okay, so for all these 3 laws, first of all, a cannot be 1. A is more than 0. Also, the values for m and n must be positive. Okay, so let's look at part A and see which one we can use. Alright, so if you were to examine it carefully, you see there's a number 2 in front of your log. So we can actually apply the power law by bringing it out. Okay, so here you have to be careful. You need to bracket it because we're actually squaring the whole of 2/5. We're squaring the whole of 2/5 and not just 2. So if you don't put a bracket and just write it as log base a to the power of 2 over 5, then this is incorrect. Okay, so this is what I mean by knowing the law and also know how to apply it correctly. Right, so likewise, I'm going to bring this 3 up. So that means I'm going to cube the whole of 2/3, so I need to bracket it. Okay, I'm going to simplify further. So 2/5 times 2/5 will give me 4 over 25. And then 2/3 times 2/3 times another 2/3 will give me 8 over 27. And then if you look at it again, I can use the quotient law because I have something minus something. And that will give me just log base a, 4 over 25 divided by 8 over 27. And for that, if you use your calculator, I think you will get 27 over 50. Alright, so that's how we do part A. Let's look at part B. Okay, let me see whether I can do part B here. Alright, so we need to combine them into one single log. So basically what I'm going to do is I'm going to work on this first. This one, because I can use the power law for that, I can just bring the 2 up. So that will give me log base a2 squared. Okay, then I need to do something to 3, right? Because basically if I'm going to use product law or the quotient law, I need to express it as log something, right? Then I can use the product law. Okay, so here then I need you to recall another what do you call that, special my goodness, nowadays I'm really lost for words. Special case of the log. All right, if you were to recall, log base a actually gives you 1. So I can actually write 3 as 3 times 1, and I can write 1 as log base a. Okay, I use base a because what I'm given here, it's base a, the one that put the arrow there. If you're given base b, then you just use log b base b. Okay, whichever base you're given. So here I can again apply the power law just by taking the 3 out. So I will get log base a cubed. All right. Okay, so let's go back to the original questions. So that means I can write 3 as 3 log base a. 2 squared is 4. And then I'm going to bring the 3 up. That will give me log base a cubed. And here I can express it as a single log by using your product law. That will give us log base a cubed times 4. That will be just 4a cubed. Okay, so it's actually quite fun doing this sort of question. Just playing around with the three laws. Okay, just playing around with it. Right, let's look at part C. All right, so part C appeared to be pretty complicated, but not to worry. Actually, the more complicated the problem is, the easier to solve it. It's when, things look like very peaceful, like no problem, and that is the worst thing because you don't know where exactly the problem lies. Okay, never mind. So let's look at, there are 4 terms there, so let's zoom into the first 2 terms. So the first 2 terms easily just use the product law. So you see, this is what I mean by the more difficult it is, the easier to manage it. So that will be just 50 times 8 over 25. And then this one here, you can just easily use the power law. You see that's a number 2 in front of a log. Just bring it up, so that will give us 10 squared. Okay, simplify this guy here. So 50 times 8 over 25, that will give you 16. 10 squared will be 100. Okay, if you're not confident to just combine 3 of them at one shot, you can just do this 2 first. That will give us log base 1600, 16 times 100, so 1600. And then after that, apply the quotient law. Okay, so you really don't need to get worried if there are too many things. You just break it down, decompose into a smaller portion. Okay, right, so 16,000 divided by 25. Oh my god, I don't have a calculator. Okay, so that give us 1600 divided by 25 is 64. So that's it. Okay, it's even easier than part B, even though it looks complicated. Okay, let's look at question 14. Right, so for question 14, 14, there are 2 parts, 14a and b. So let's look at 14a first. So 14a, you're given log base 4 y is equals to a, and also log base 8 2y is equals to b. Alright, so what I'm going to do in both cases here is to convert them into indexed form. So to convert into index form, let's start off by looking out for the base. Alright, so if you look at log y base 4 equals to a, the base is 4. So that means 4 to the power of a is equals to y. Alright, so we're going to call this equation 1. And then for the second one, if you look at it carefully, the base is 8. So 8 to the power of b is equals to 2y. Alright, I'm going to call it equation 2. So what I'm going to do here is just to substitute equation 1 into 2. And I will have 2 times 4 to the power of a equals to 8 to the power of b. Right, so the next questions you need to ask yourself is this number 2, number 4, and number 8. How are they actually connected to one another? Yes, right. So we can actually write 4 as 2 to the power of 2. So that gives us 2 to the power of 2a. And 8 to the power of b, 8, I can write it as 2 to the power of 3. So multiply with b will give you 2 to the power of 3b. Alright, so 2 means 2 to the power of 1. So this one here, you can apply this rule that I've learned in the chapter under indices. So that will give us 2 to the power of 1 plus 2a equals to 2 to the power of 3b. And since we have the same base on both sides, we can just equate the power. So 1 plus 2a will just be equals to 3b. And we have to make 2a the subject. So subtract 1 on both sides. So 2a will just be 3b minus 1, which is what you are required to show. Right. So that's how we do 14a. Not too difficult. Let's look at 14b. Alright, so we're going to do the same thing as if we're just going to convert all these logarithmic function or logarithmic equations into index form. So let's zoom into the base. So this is base 3. So this is just basically 3 to the power of a equals to p. And then for the second one, likewise, zoom into the base, which is 27. So this is 27 to the power of b equals to q. Alright. So the questions require us to form an equation involving p and q. So we're going to take p divided by q, which is 3 to the power of a divided by 27 to the power of b, and that is equals to 3c. So again, if you look at it, how are all these numbers connected to each other? Like 3, 3, 27. Yes, you can actually write 27 as 3 to the power of 3. And this one here, you can apply these rules. Okay, so that will give us 3 to the power of a minus 3b equals to 3 to the power of c. And since we have the same base, we can just compact the power. And that's how we make c in terms of a and b. Right, and that's it. So if you look at both questions, look at this question 14, you will find that whatever you've learned in the chapter of indices are very important. So if you have forgotten all the rules in this chapter, please revise all the rules again. Right, let's look at question 15. I think we can simplify this equation given here. Alright, I'm going to multiply both sides by square root 5. So that will give me y equals to square root 5 times square root 20 times 10 to the power of negative 3x times 10 to the power of 5x. Alright, so this we can actually apply what we have learned earlier on in the chapter of sets, where we can have square root a times square root b. That will give you square root ab. So therefore square root 5 times square root 20 will give you square root 5 times 20. And this we can actually apply what we have learned also in integers. If you have the same base, and if the operation is times in the middle, you can just add the power. Right, so that will give us 10 to the power of negative 3x plus 5x. Alright, 5 times 20 will give you 100. So we are finding square root of 100, which is 10. Okay, 10 meaning 10 to the power 1. And here again, we can apply the same rule. This one here. That will give us 10 to the power of 2x plus 1. Alright, so basically, I have two equations here. Okay, this will be my first equation. And then the second equation given it's log y minus mx is equals to c. Okay, so what we're going to do is either you convert equation 1, okay, into a logarithmic form, or you convert equation 2 into index form. I think I'm going to do, it's easier to convert equation 2 into index form. But before that, we need to know that LG, it's the symbol for common log, which is log base 10. So therefore, LGY is log base 10 y, and then I'm going to bring the negative mx to the other side. That means I plus mx on both sides. That will give us log base 10y equals to mx plus c. Alright, and to convert that to the index form, alright, always start off with looking at the base here, which is 10. So that will give me 10 to the power mx plus c equals to y. Okay, so now you see that both equations are in the same form. Alright, so we can actually do a comparison. We can actually let equation 1 equals to equation 2. And we will have 10 to the power of mx plus c, which is equals to 10 to the power of 2x plus 1. So therefore, mx is equals to 2x. So that gives us m equals to 2 and c is equals to 1. Alright, so that's how we solved question 15.